Welcome to the Deep Dive, your essential shortcut to navigating complex regulatory landscapes. Today, we're zeroing in on, well, a really critical challenge facing anyone placing machinery in the European market. It's about proving your instructions are clear enough to guarantee safety. And look, this isn't just a suggestion, it's a compliance bottleneck that can actually dictate market access.
Exactly. Our mission today really is to analyze the precise relationship between the EU Machinery Directive, that's 2006/42/EC specifically, and the mandatory clarity standard it demands.
Right.
We're looking at why an international linguistic standard, ASD STE 100 or simplified technical English, has pretty much become the de facto tool for achieving this regulatory compliance.
Okay, let's unpack this then.
Yeah.
Because we look at the core argument in our sources. It suggests, a profound shift in thinking for engineering and compliance teams.
How so?
It seems compliance with the EU safety law starts not just in the hardware, the physical design, but fundamentally in the language used in the instruction manual.
That's absolutely the crux of it. Let's maybe establish the foundation first, the regulatory imperative. Directive 2006/42/EC applies right across the board: machinery, safety components, lifting accessories, interchangeable equipment, you name it.
Okay.
To legally place your product on the EU market, compliance is simply mandatory. There's no way around it.
So the mechanism for proving compliance then, it lies heavily in the paperwork, the documentation. What does the directive specifically mandate regarding that?
It's extremely clear on this. Article 5 states that the manufacturer must ensure the entire technical file as detailed in Annex 7, Part A, is available. And critically, this file must include the necessary information such as instructions. Now, once you put that CE marking on...
Which confirms compliance, right?
Yeah, confirms you believe you've met the requirements. But the real weight of the law, the substance, rests on the essential health and safety requirements, or EHSRs. You find those in Annex M.
Okay, we've got the framework under Article 5, but where do the EHSRs really put the pressure on the documentation team? What demands does the EU place on the wording itself?
This is where the directive gets very specific about linguistic clarity. You need to look closely at Annex I, Section 1.7.4.1. It details the general principles for actually drafting instructions.
And what are those principles?
Well, beyond just covering the product's intended use, instructions have to anticipate and cover any reasonably foreseeable misuse.
Reasonably foreseeable misuse.
Wow.
That sounds like a huge burden on technical documentation, trying to preempt user error.
It is. It really is. But the critical linguistic requirement follows immediately after that. It says if your machinery is intended for use by non-professional operator,
which covers a lot of equipment.
Exactly. Then the wording and layout must account for the level of general education and acumen that can reasonably be expected from such operators. Now, think about that across, 27 plus member states, different languages, different educational backgrounds. That sets a remarkably low bar and a highly challenging one for assumed technical literacy.
So in essence, you're legally required to write simply, unambiguously, especially for potentially the least sophisticated user who might encounter your product anywhere in the EU.
That's it.
What happens if the documentation fails that clarity test? Say, if that lack of clarity contributes to an accident or a hazard, what are the material consequences?
The consequences are, dire. They're defined by Article 11, the Safeguard Clause. If any member state finds that machinery, even one with a CE mark, endangers health or safety, and remember, failure to satisfy essential requirements like clarity definitely falls under this.
Then what?
Then they are obligated to take strong measures. We're talking withdrawing the machinery from the market entirely, prohibiting its initial placement or putting it into service, or severely restricting its free movement.
That's total market exclusion. Triggered by bad writing, essentially.
Triggered by deficient language, yes. Preventable human factor risk.
When you frame it like that market exclusion driven by lack of clarity, it really puts the inherent risks of just using standard English into sharp focus, doesn't it?
Absolutely. Standard English, it's rich, it's expressive, but it's a major vulnerability in a safety-critical technical context.
How so?
Well, our sources point out something interesting. English has roughly 3 times the vocabulary of languages like French or German.
3 times?
Yeah. That redundancy means we have hundreds of synonyms for the same basic concept. That breeds ambiguity, inconsistency. Technical writers often use different words just to vary the text, make it sound less repetitive.
Sure, that makes sense from a writing perspective.
But that variation makes the product definition unstable. It makes it difficult for a global user, maybe a technician reading it in translation, to process it consistently.
I get the general risk of having too many words meaning the same
Yeah.
thing, but can you give us a concrete example where standard English creates ambiguity that maybe a translator just can't fix?
Okay, sure. Take a really common instruction verb. Replace. Simple enough, right?
Seems straightforward.
But if an instruction says replace the gasket, what does that actually mean? Does the user put the old gasket back? Or do they discard the old one and install a brand new identical part?
Ah, I see. It could mean either.
Exactly. In standard English, the author can leave it vague. But here's what's fascinating. In many other languages, let's say German or French, the translator is forced by the grammar, by the verb structure itself, to distinguish between those two actions. They have different words for put back versus substitute with new.
So if the original English is vague,
The risk persists. The translator has to guess, or maybe the company hasn't defined it. And that ambiguity remains right up until an accident happens.
so that lack of forced precision in standard English creates a gap between author intent and user understanding, and that drives up risk. What about costs? Are there financial implications too?
Oh, definitely. That ambiguity and complexity just compound downstream. When language is, let's say, sloppy or complex, even subject matter experts struggle during the validation phase.
Right, checking if it's accurate.
Yeah, and you end up with descriptions that are maybe about right instead of technically spot on. Plus, the lack of consistent terminology means translation memory tools. The software that helps reuse translated phrases struggle to find matches.
Which makes translation.
Highly complicated, more expensive. It drives up costs significantly. And think about the delays it increases time to market, causes downtime for high-value assets. Medical scanners, aerospace equipment, where every hour that thing sits, idle costs, as the sources say, big money.
Okay, that makes the case for some kind of controlled language almost undeniable. Which brings us to ASD ST-N100, or STE. Developed, I understand, by the aerospace and defense industry back in the 70s and 80s.
Precisely. It came about because they had non-native English-speaking maintenance staff performing increasingly complex tasks.
And the manuals weren't clear enough.
The existing documentation was failing, causing errors, incidents. They needed a technical writing standard that eliminated that structural complexity, that vocabulary complexity.
Right. So let's introduce ASD STE-100 properly as the solution here. It's an international standard, a controlled language. How is it actually structured? What does it consist of?
STE is built on a foundation that's, well, very restrictive, but that's where its power comes from. First, it's got a clear set of writing rules, somewhere between 53 and 65, depending on how you count sub-rules.
Okay.
These rules are quite distinct in their balance and completeness. They ensure global consistency. Second, it relies on a core general vocabulary dictionary of only about 900 approved words.
900 words. That sounds tiny compared to standard English.
It is very restricted. And finally, there are guidelines for handling manufacturer-specific terminology, what SDE calls technical names and technical verbs.
It really seems like that restriction, that power of restriction is the key thing. Forcing precision onto a language that, as you said, often prefers ambiguity. How does that work in practice?
It operates on a core principle. One word, one meaning. Every word on that approved list of 900 is simple, flexible, commonly used. But it has only one allowed meaning and one specific part of speech assigned to it in the STE dictionary.
Can you give an example?
Sure. Take the word check. In STE, it's only approved as a noun, meaning an evaluation, a test, like do a check of the system.
Okay.
It's strictly forbidden as a verb. You can't write check the system. You'd have to use an approved verb like examine or test or measure, depending on the specific action. This prevents confusion with other actions.
Got it. Let's move into the practical side then. How does this rigorous standardization, these rules, objectively guarantee the clarity that the EHSRs demand, especially for those non-professional operators?
It uses objective, measurable rules to achieve that legally required simplicity. For instance, STE enforces mandatory sentence length limits. Procedural sentences instructions are capped at a maximum of 20 words.
20 words,
Well,
max.
And descriptive text explaining something can't exceed 25 words. That immediately eliminates those long, confusing, nested clauses that often derail comprehension, especially for non-native speakers or people reading quickly under pressure.
20 words for a procedure? That sounds incredibly tight if you're describing a complex technical action. How do technical authors even cope with that?
It forces them, really. It forces them to be hyper-efficient, to break complex tasks down into simpler sequential steps. It's a discipline, no doubt about it.
Another rules.
Yes, another key one. The rules require using the imperative mood, the command form for instructions. You must write remove the plug, not the passive, slightly vague construction like the plug ought to be removed or the plug should be removed.
Makes sense. Clear action, clear responsibility.
Exactly. It ensures immediate accountability and action clarity. And maybe the most beneficial rule of all, Rule 1.1. Use only approved words from the dictionary or your defined technical terms. That guarantees perfect vocabulary consistency. That consistency rule, Rule 1.1, really seems to highlight the utility of STE, especially when you're dealing with complex terminology, maybe across different documents or authors.
It really does. Think about needing to describe different types of inspection, for example. Instead of trying to invent or use complicated, maybe unapproved verbs like trying to say fluorescent penetrant inspect, which is awkward, hard to translate.
Right.
STE forces consistency. You write, do a fluorescent penetrant inspection. That clear structure to an adjective noun is maintained whether you're talking about an ultrasonic inspection, an infrared inspection, or any non-destructive test.
That predictability must be key.
It's paramount. For clarity, for consistency, and actually for efficient machine translation, too.
So looking beyond just ticking the box for regulatory compliance, what are the tangible bottom line benefits companies see when they really commit to implementing STE?
The financial benefits can be substantial, mainly because you're eliminating linguistic waste. We typically see that maybe 20% to 25% of words in standard technical text are actually redundant. They don't add meaning. Just extra words.
Pretty much. By cutting that volume and enforcing consistency, you radically improve efficiency. Because you're using the same 900-word core dictionary and the same sentence structures again and again, the repetition means translation memory match rates increase dramatically.
And that leads to?
That commonly results in at least a 35% reduction in translation costs, sometimes more.
Wow, 35%. For global manufacturers dealing with maybe 10, 20 target languages, that's a massive competitive advantage.
It is, and it's built on that foundation of consistency, which actually extends beyond just cost savings. Think about accuracy and teamwork.
How so?
Whether the documentation is being written by a professional technical author, or maybe a field engineer sending notes back, or a subject matter expert contributing, they're all working with the same restrictive vocabulary and the same rule set.
So everyone's on the same page, linguistically.
Exactly. It ensures high consistency across globally dispersed writing teams. And regarding accuracy, because frankly, it's just about impossible to write anything truly vague or woolly in proper STE, it forces authors to actually confirm all the technical details before they commit them to text. They have to know exactly what they mean because the language won't let them fudge it. That fundamentally improves the validation process itself.
Okay, so let's say a large global manufacturing company hears this, recognizes the risk, sees the benefits, and wants to implement STE. What are the actual steps? You can't just hand them the dictionary and the rule book and expect immediate compliance, surely.
Oh, absolutely not. Implementation is definitely a process. It requires building a strong baseline first. The most critical step, really, is establishing the company's specific terminology.
The technical names and verbs you mentioned,
Precisely.
Right?
This usually involves mining their existing legacy documents, thousands of pages sometimes, to identify and then define the, say, 1,500 to 3,000 company-specific and product-specific terms they'll need. Then classifying them properly as approved technical names and technical verbs within the STE framework.
So getting the terminology dictionary right is step one. Then comes the training, presumably, teaching people this new writing discipline.
Exactly. Proper training is absolutely essential. It usually takes about 2 to 3 days, typically. It needs to be comprehensive, covering the theory, yes, but also involving lots of hands-on exercises.
Practical application.
And crucially, dedicated rewriting sessions where participants actually convert their own company's legacy content into compliant STE. That makes it real. And to ensure quality learning and robust discussion, the sources recommend keeping class sizes small, ideally between 5 and 15 participants.
Right, focused learning. And finally, because this sounds like a pretty significant operational shift, not just a one-off course, I imagine ongoing support is important too.
Absolutely vital. Post-training support, whether that's providing proofreading services, editing assistance, maybe compliance reviews for a period, it's critical. This continuous support helps writers really embed the new discipline into their daily workflow and ensures the company achieves and maintains auditable compliance with the standard over time.
This deep dive has been incredibly illuminating, really. I think the key takeaway for compliance managers, engineering managers listening is crystal clear. Meeting the EU Machinery Directive's stringent clarity requirements, specifically that Annex Y in 1.7.4.1, it's fundamentally a linguistic problem, a structural language problem.
Hmm.
And ASD/STE 100 provides a standardized, objective, and crucially, quantifiable solution to mitigate that huge regulatory and financial risk of an Article 11 market withdrawal.
Which, raises an important question.
Okay, what's the final challenge? What should we leave our listener mulling over?
Well, think about this. STE was developed by a massive multinational committee, linguists, engineers, operators specifically, to prevent catastrophic multi-million-dollar accidents in aerospace, an industry where technical complexity is arguably at its absolute peak.
Right, high stakes.
Extremely high stakes. Now, if the EU legally requires your documentation to be clear enough for the least educated, potentially non-professional user across Europe, what specific unaddressed linguistic risks are lurking in your current non-STE compliant technical documentation right now? Risks that could make the language of safety your biggest liability. You really need to find those risks before the regulators do.